Good evening, everyone. Just confirm whether the audio and the video is clear to you or not. Let everyone join, then we'll start off with our lecture. Okay, so today is the second day in our concept mapping series, and today we'll be revising the ABCE model of flower development. Good evening, Mayank. Let everyone join, then we'll begin with our class. Okay, today we'll be discussing about the ABCE model of flower development. It is one of the most important topic when we look into unit number 5, that is developmental biology. In that unit, this particular topic holds a very important place. So let's begin with our class now. Other students would join in the time being. So before starting the video, if you're new to our channel, do not forget to hit the subscribe button. Good evening, Niharika. In addition, make sure you download the application from the Android as well as from the iOS devices. It is available on both the devices. In addition to that, we have a lot of courses running for you all with live classes on our application, and the most important course running for the time being is this crash course, which is related to the structured and very organized revision if you are targeting the June 2023 examination. So if you wish to enroll, download the app and get yourself enrolled over here. You'll be getting a PYQ pointers hard copy in your doorstep delivered. Okay, good evening, Khushi. In addition, we also have various other contents available for you all. Mock tests are there. We have notes, booklets, hard copies available. In addition, we also have the full course running for you all for the June 2023. So this was about this particular thing. Let's start with the revision of the most important topic that we are going to target today, which is related to the ABC model of flower development. Okay, so first of all, try to write down what do you understand by the term flower. Anyone, try to define what a flower is all about. We all have, like, we all use this particular word time and again in our daily basis. On daily basis we use it. So just try to write down कि हम एक फ्लावर को किस तरीके से डिफाइन करेंगे अगर हमें उसे टेक्निकल टर्म्स के अंदर डिफाइन करना हो. Anyone, try to write down what do you mean by a flower. We have 6 students in the class. Make sure you're there in the class by the end, till the end of video. We'll be solving out few previous year questions as well. It would help you out. Okay, so okay, reproductive stage of plant. What else? What do you understand by a flower? Anyone? Niharika, Mayank and other students. We have in total 8 students. Try to write it down. It is the reproductive stage of the plant. What else? Try to define it. It's very simple. We all use it in daily basis. Yes, very good. It's a very simple definition but a very important definition. We can also call this stage before the development. Okay, or we can call it as the stage before the fruiting time. Very good, excellent. So flower is the reproductive stage of the plant, and the formation of the flower, the way via which a flower would be produced in the plant, it is dependent upon, or it is like explained via the ABC model of flower development. Let's look into the structure of flower first. So when you look into the structure of flower, we have in total 4 whorls to it. Like after this class, whenever you take a flower in your hand, try to observe there are in general 4 whorls to a specific flower. Try to write down the name of all the 4 whorls. Anyone? Khushi, Niharika, others also try to write down the name of all the 4 whorls. It is sepal, then we have petal, then we have stamens, and then we have the carpels, right? So this is the basic whorls in a particular flower. When you look into in a cross section, so innermost, then you have outer, then the third one, then the fourth one, right? So the outermost is sepal, then we have petal, then we have stamen, and then we have the carpel, right? So these are the 4 main stages, the 4 main whorls of a flower, right? Now let's try to understand it via the help of various models, various genes that we have. So you have 4 whorls. What are the name of the whorls? It is sepal, petal, stamen, and carpel, right? So now we have 3 genes. Gene A, or the class, there are 3 main classes of the genes depending upon which we have the complete whorl formation. You have gene A, gene B, and gene C, right? So there are 3 classes of gene: class A, class B, and class C. In every class we have various genes being present. In class A, what do we have? We have epitala 1 and epitala 2, right? In class B we have epitala 3 and pistillata, and in class 3 we have the agamus, right? These are the 3 main classes of genes that we have discussed, that you must have read about it in your preparation time, right? Now on one side you have 4 whorls, on the other side you have 3 of the classes of genes. Now the combination of these genes would be helping out in the formation of the whorls. Let's look into that. So when you look into the sepals, so sepals are created via class A genes functionality. Then in petals you have class A plus class B genes working together. Then in the stamens we have class B plus class C genes working together, and then in the carpel you have the class C genes working together. So this is something which you also have to remember in addition to the main pointers. Now there is one more important point, that we have class A gene and class C gene. They both are antagonist in nature. This is one of the most important property, that they both are antagonist in nature. What is the meaning of antagonist? That when class A is absent, class C would come and work over there. If by chance class C is absent, so class A would come and work over here. So, and when you look into the CSIR NET questions and the DBT or any other competitive exam questions, you will see that every time in one way or the other you are getting the questions of mutation type, that there was a mutation in a specific gene, whether it could be class A, B, or C, depending upon whatever is asked in the examination. Based upon that you are asked that what is the final mutation, or what would be the final synthetic product available, right? For example, let's consider a scenario, let's consider a case in which class A gene got mutated, let's say, right? Now let's try to analyze what would be the result of that. So normally you have sepal, you have petal, you have stamen, and you have carpel. Sepal gets formed by A gene, petal gets formed by A plus B, stamen gets formed by B plus C, and carpel by C. Now it is saying that A class got mutated. Now what will happen? A would got mutated, so A would not be working. But we know one more scenario, that A and C are both antagonists to each other. So apply this case into the question given to us, into the case that we have taken up. Now what will happen? A, in place of A, the C would be working, right? Now just check what would be the scenario. If in the first world we have the class C gene functioning, what would be the case? The carpel would be formed over here, right? Then B plus C forms stamen. So second whorl would be stamen, third whorl normally would be stamen, and fourth whorl would be carpel. So what would be the final result of case A getting, or the class A getting mutated? You would be having first carpel, then stamen and finally carpel. So this would be the case if by chance class A gene got mutated. Just check whether this particular point is clear to you or not. If yes, then we'll proceed further to further cases, and then we'll discuss few questions as well. Just check whether it's clear or not, everyone. We have 6 students in the class. Others also, Niharika, Mayank. Very good. Let's move forward. Now just look over here. When we look into the ABCE model, so in the ABCE model you have the world meristem identity genes and world floral identity genes. So the floral meristem identity genes would be converting shoot into flower, and the floral organ identity genes would be converting, or they would be controlling the flower identity. These are the various genes that would be helping in the floral whorl identity, and then the floral meristem identities are controlled by all these things. We are not going into the depth of this. I have just given you an overview. If you wish to revise it properly, then we have a full crash course running for you all. You can join in that particular course. So there are 4 whorls that depends upon 5 homeotic genes. What are the name of the genes? I have already told. These are the names: epitala 1, epitala 2, epitala 3, pistillata and agamus. So you have sepal, petal, stamen and carpel, right? Now this was about the complete segment. Let's discuss the very first question for you all. The question is, individual and the overlapping expression of the homeotic genes in the adjacent whorls of a flower determine the pattern of floral organ development, right? In an Arabidopsis mutant, the floral organs are distributed as follows. So what happened? In the whorl A, you had the carpel being formed. In the whorl B, you had the stamen. In whorl 3, you had stamen, and in the fourth whorl you had the carpel again, right? Now you need to find out that loss of function mutation in which of the following genes could have caused this pattern of floral organ development. This is a 2016 year question. Try to find the answer for this particular question, everyone. And you can see the question, there are just 3 important things that you need to remember, and based upon that you can easily find the answer in the examination. Get the answer for this question. Okay, Khushi is marking the answer A. Others also quickly mark the answers. Take your time, get the answer for this question. Okay, Rajesh is marking 1. Others also give it a try. Very good, very good. Let's check what is the answer for this. See, I've explained the same case over here today. Like just now we have discussed the same case. And it is saying that carpal, stamen and carpal is getting formed. Just check over here. We discussed the same scenario. Carpal, stamen and carpal. So it was in class 1. In class 1 you have AP1 and AP2. So look into the options. When we look into the options, class A gene is AP2 as depicted in the question. So answer is option number 1. Very good. All of you got the answer correct. Let's move forward to the next question. So now this particular question is again a mutation type. It is again 2016 question. Question is, according to the ABC model of flower development in Arabidopsis as shown below, you have A, B, C, several genes transcription factors, example AP1, AP2, AP3, agamus, all of them are involved. It is asking, in the first you have sepal, then petal, then stamen, then carpal. It is asking which of the following statement is correct. Get the answer for this question. First statement is epithala 2 transcribe expressed during the sepal and petal development. Second option is agamus AG is considered as class A gene. Third option is AP1 expressed during carpal development, and fourth option is AP3 expressed during sepal development. You need to find out the correct option for this particular question. It's very easy, like a very direct factual question has been asked. Get the answer for this particular question, everyone. Give it a try. If you eliminate it also, you can, like, if you start to eliminate the options which are incorrect, you can easily reach to the answer. Okay, let's check the answer for this question. Answer for this particular question is option number A. Very good, all of you got the answer correct. So agamus is not class A gene, it is class B gene or class C gene. Yes, in class A you have AP1, AP2, class B you have AP3 and pistillata, and agamus is class C. So it is class C gene, so incorrect. Then AP1 expressed during the carpal development, incorrect. Then AP3 expressed during the sepal development, incorrect. You have first option, that is AP2 transcribes the transcripts expressed during the sepal and petal development. Okay, answer for this particular question is option number 1. Very good, 3 of you got the answer correct. And Mayank, I hope your doubt is clear now, right? Next question for you all. In agamus mutants, flower within the flower phenotype, which of the following statement is valid? It is saying agamus is mutated. That means class C genes are getting mutated. You need to find the correct answer for this particular question. Get the answer for this question, everyone. Give it a try. Done, everyone? Quickly mark the answers. Okay, others also get the answer for this question. Okay, very good, very good. That means you all have understood the main concept. Others also quickly mark the answers. Then we'll solve it out together. Done everyone? Let's check the answer for this particular question. Answer is option number 4. Very good. All of you got the answer correct. Excellent. So the question is saying that class C gene got mutated. So if the class C gene got mutated, what will happen? Class C would not be working. Then you will be having class A expressing in all of them, and class B would be expressed in the second and third whorl, right? So the answer would be option number 4. Class A genes are expressed in the whorls, in all the whorls, and class B are expressed in the second and the third whorls, right? So answer is option number 4. I hope this question is clear to everyone. If yes, do let me know in the comment sections below, and just let me know, are you liking this concept mapping series, or should we switch back to the question series only? Because some students are saying that they want the concept mapping to be continued, and some are opting for the question series. What is the preference you would like to have from your end? Just let me know, and in the same manner we'll be continuing the further marathon classes then. Just let me know everyone. Yes, question series only, or along with the mapping concept you want to have the marathon classes, because we'll be continuing these classes every day till Saturday. So just let me know about it. This was about for today's class. We have completed a topic. In addition to that, we have completed 3 questions as well. Concept mapping, concept with PYQ. Okay, okay. But for that you have to share it to as many students, as many of your friends as possible, because let everyone join in the live session and let it be more interactive from the students end, so that many students can get benefit out of it. Okay, so this was about for today's class. I hope it was helpful. Tomorrow also we'll be discussing a important concept. Along with that we'll be having few questions discussed. Okay, concept mapping and PYQs. Okay, okay, we'll be moving like for this week, let's continue with the concept mapping and PYQ itself, and then we'll decide for the next week afterwards. Okay, and those of you who wish to join in the crash course, you can join in the crash course. We have a course running for you all for structured revision every day early morning 8:30. So if you wish to join in there, you can join and get yourself the PYQ pointers hard copy as well for better revision. Okay, bye everyone, take care.